4.6, negative variations. Before we move on in this video, let's just talk about the other variations that we've learned so far. So we have direct variations, and they go through the point 0, 0. We have indirect variations, and they do not start at 0, 0, but they both have positive slopes. Okay, it's rising from left to right. Whereas negative variations, the reason why they have negative is because they will always have a negative slope. That's connected with this line right here. The slope will always be negative. Now, negative variations have two variables and two numbers, just like indirect. And we have a k, a slope of a constant of variation with a slope. But like I said, this slope will always be negative. We have a b, we have an initial value or a constant. These relationships can be expressed in a variety of ways. You can have words, equations, tables of values, and graphs. So example number 1, we're going to be talking about relationships that are negative. So it means that they start out and then get lower and lower and lower. One really common example will be the balance left on a loan. So example 1, I wish to purchase a new couch, but I do not have enough money to do so. My grandma is a wonderful human being and wants to help me out, but also wants me to learn a few life lessons in saving. The couch cost $750, and she said that I could pay her back $50 each month until the entire thing was paid back, interest-free. Examine the relationship between the amount of loan left and the number of payments. So, we know that we have the amount of loan left, and we have the number of payments. Just like with indirect, we have a little cheat. When we look at the initial value always gives us the units of the dependent variable. Gives us the units of the dependent variable. It's my just short form for dependent variable. So, it's in dollars. So the amount of loan left or the number of payments that have been made. This one right here, that's going to be in dollars. So we know for certain that this is going to be our dependent variable. I'm just going to go through right now and highlight every single time a dependent variable will come up. And then that means that we know what our independent variable is. That's going to be the number of payments. Now the initial value I highlighted in green because that's how much the loan is for. That's the constant. That's the same thing as our constant. So I'm just gonna highlight that. And whenever we have a cost per, so this one is $50 each month. So the payment per month is going to be 50. We know that that's going to be our constant of variation. So, if we were to answer this question right here, we know that our dependent variable is going to be amount of loan left. And we know that the independent variable is number of payments. So if we were just to use words to describe this, we would say the amount of loan left, let's just call that the balance because we know that from the first unit. So the balance of the loan or depends on the decrease of $50 per month plus $750. So our dependent here is going to be balance, which we're going to call B. Our constant of the slope is going to be negative 50 because we're paying back 50. We're making it less by 50 each month. Our independent variables is going to be payments, number of payments. We're going to call that P. And the initial value, or the constant, is going to be $750. So we're going to use our form here and say the dependent variable, which is our balance, equals the initial value, which is 750, minus 50 times P. Now I don't want you to get confused here with this if it's better that we just say 50 instead of minus 50, because the negative is already embedded in this here, so I don't want you to say minus 50. So I'm just going to take that that negative away actually. Okay, so if I were to color code this, I would say the balance, which is our dependent, equals our initial value, which is 750, minus the constant variation, which is 50, times our independent variable, which is P. Great. So now we're going to make a table. So we know that the independent always goes on top, so that's payments, and the balance, or the dependent variable, which in this case is the balance, will go on the bottom. However, you know me, I like to have a little bit of a vertically oriented table here. So I'm going to say payments here, I'm going to say balance, and I'm going to leave this right here open for my coordinate points. So if I've made 0 payments, I know that my balance is 750. If I've made 1 payment, it's going to be 700. If I'm going to make 2 payments, it's going to be 650. 3 payments, 600. 4 payments, 550. And 5 payments, 500. So if I were to write down my coordinate point, it would be 0, 750, 1, 700, 2, 650, 3, 600, 4, 550, 5, 500. Okay, so now what we can do is we can make our graph, because we have all the coordinate points here. So I'm going to just make it smaller so that we can see the whole thing. Of course. There we go. So on the bottom here, we're going to say number of payments. And on top here, we're going to say balance of loan. So I know that this will fit as 1, 2, 3, 4, and 5, and 0. But I don't think that it will, I don't think that'll fit on here. Just have a hunch here, folks. So I'm going to show you kind of a foolproof way to figure out what the scale can be. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what I'm going to take is my biggest number. Let's just say 800. Let's round up. I'm going to say divided by 12. So I know that in order to fit perfectly, each of these has to be 66. So if I go up by 100, I know for certain I'm going to be safe. So 100, 200, 300, 400, 500, 600, 700, and 800. Okay, the balance of the loan, we want to make sure that we know that the units are in dollars. So just going to change the colors up here. Maybe I'll choose red. Ooh. So I know at time 0, I'm starting at a balance of $750. After 1 month, it's 700. After 2 months, it's 650. After 3 months, it's 6. After 4 months, it's 550. After 5 months, it's 500. So again, same with this one. I'm just drawing the line here to show the general trend, the general trend of what's happening. It's actually discrete data. It's not like you're paying your grandmother, however many, cents per second of the day. You truly only do make lump sums. So we would call this discrete data. And it could actually just be drawn like that because it's not like you can make 4.5 payments. Your grandma's going to be a little bit more flexible than your bank, but in general, you'll just be paying her once a month. So this line right here just kind of shows the trend. So you'll notice that this also, just like our indirect, it does not go through 0, 0, but it still is data that forms a line.